Welcome all to my next video. In this video, I am going to explain about fractional distillation. The word distillation refers to purification of any liquid by evaporation and recondensation. Any liquid while heating gets evaporated and while cooling gets condensed and collected as a liquid. So this process is called distillation. And fraction is nothing but more than one components. Fraction means more than one components are present in the liquid. So this fractional distillation technique is used for purifying more than one liquid present as a mixture in a impure liquid. So here we can consider this benzol as an example. Benzol is a liquid which contains more amount of benzene and toluene along with other impurities. So benzol contains more amount of liquids. In the more amount of liquids, the major component is benzene and toluene. So here from benzol we can able to purify the benzene and toluene separately. So since it is more than one liquid purification, we can call it as fractional distillation. And here this is the apparatus setup, experimental setup for this fractional distillation. So here in the round bottom flask, we have to take the mixture of impure liquid. The impure liquid can be taken in the round bottom flask, and the round bottom flask will be heated from the bottom. Inside the round bottom flask, inside the liquid, we have to keep porcelain bits in order to avoid bumping. So while heating, the liquids get evaporated and comes above through this tube. So there is a apparatus, extra apparatus than the distillation apparatus. This apparatus is called fractionating column. The fractionating column here, both the liquids tries to come above the round bottom flask. So one liquid, so by considering this example, if you consider benzene and toluene, while we are heating 90 to 100 degrees, only the benzene has to get evaporated because the boiling point of benzene is 80 degree and the boiling point of toluene is 110 degree. So at the initial stage, only benzene alone gets evaporated and comes above the round bottom flask. Through this fractionating column, it will go to the still head. And if you are heating more than 120 degrees, the toluene also gets evaporated and comes through this fractionating column and comes to this still head. So in the still head, there is a thermometer which can measure the temperature of the vapor. The vapor then passed through the condenser. The condenser has two tubes, one is inner tube and another one is outer tube. The vapor passes through the inner tube, comes through the inner tube, and the liquid which is passed through the outer tube, which comes only through the outer end. So the outer tube contains liquid in order to cool the inner tube. The inner tube, inside the inner tube, the vapor while passing through the inner tube gets condensed because of the outer liquid and converted into the liquid back again and collected through the receiving bed and collected at the end. Now, what is the role of this fractionating column? So when you compare the fractional distillation with the simple distillation, the only extra apparatus is fractionating column. So what is the role of fractionating column? What we are expecting in reality. So what we are expecting is, if you are keeping 90 degrees or 85 degrees, only the benzene alone gets evaporated. And if you are keeping more than 110 degrees, then only the toluene has to get evaporated. This is what we are practically or theoretically we are thinking. But in reality, benzene and toluene are highly miscible. Both are miscible. So the benzene, while heating, it tries to take some amount of toluene also along with it. Some amount of toluene also will get evaporated along with benzene, since both the liquids are highly miscible. So beyond our expectation, benzene with some amount of toluene, both the liquid get evaporated from the round bottom flask and goes to this fractionating column. Inside the fractionating column, you can see the apparatus setup. It has a narrow path and broad, then narrow, then broad, then narrow. So while passing both the vapors, here benzene and toluene, both the vapors passing through the fractionating column. Here the vapor has to touch more amount of surface because of this narrow broad setup. So while it is touching the surface of the inner tube, the liquid which is having more volatile, it is nothing but benzene. It will not get condensed and it will pass through this fractionating column. But the liquid which is having less volatile nature, which is nothing but our toluene, will get condensed inside this fractionating column itself and comes down to the round bottom flask itself. This fractionating column is used for separating benzene and toluene in this by using this setup. During this process, during the evaporation, only benzene alone gets evaporated and passed through the fractionating column. But the toluene will not pass through the fractionating column, and the toluene, because of its higher boiling point, it gets condensed inside the air, surrounding air and surface area. It gets condensed and fall back into the round bottom flask itself. Now, after crossing the fractionating column, only benzene alone pass through the still head. And here the thermometer will show obviously 80 degree because of the benzene boiling point. And the benzene vapor alone pass through this condenser, and because of this outer cold water circulation, benzene gets condensed and collected as a pure liquid. So we have to continue the heating. We have to continue the heating till all the benzene gets collected. So completely all the benzene once gets collected, you will not get any liquid. At that stage, we have to shift, we have to change the conical flask. The first conical flask which collects pure benzene can be shifted to other place, and we have to keep a new conical flask which can able to collect a new pure toluene. So here second conical flask has to be kept, and here temperature has to be increased. Now we have to keep the temperature more than 110 degree or 120 degree. At that time, now only toluene gets evaporated. Because of more amount of heating, this toluene will not get condensed in this fractionating column, and it will pass through this thermometer and still head. Here, that time the temperature will show 110 degrees. Now toluene vapors comes to this condenser and get condensed, and through this receiving bed gets collected. So using this way, that both the liquids can be purified by this method, this fractional distillation. The benzol is a mixture of benzene and toluene. The benzol we have to take inside the round bottom flask, and while heating through this fractionating column and still head, first benzene get collected as a pure liquid. Then after collection of benzene, while we are heating the liquid to 120 degree, the toluene gets collected. So this fractional distillation technique is used for purifying more than one liquid, 2 or 3 liquids from a mixture of liquid. So another best example is purification of crude oil, petroleum crude oil. Petroleum crude oil contains more amount of liquids. Say for example, kerosene, diesel and petrol. So the petroleum fraction in the laboratory broad scale industry, so the petroleum fraction was kept in this round bottom flask, a bigger size round bottom flask, and by using this fractionating column and using this fractional distillation method from petroleum crude, first we can able to collect diesel, then petrol, then finally kerosene. So one by one we can able to collect all the 3 liquids from a petroleum crude. That is the day-to-day life example. And the special apparatus apart from other distillation in this method is fractionating column. So these are the another types of fractionating column. So the fractionating column, either this type or this type, we can able to use. The purpose of fractionating column is, while 2 vapors passing through the fractionating column, the vapor which is having higher boiling point will not pass through this fractionating column and gets condensed inside the fractionating column and fall back. The low volatile or less volatile liquid which is having lesser boiling point, that liquid alone pass through this fractionating column. So the surface area reduction is the primary key point in this fractionating column. So through this fractional distillation, we can able to purify more than one liquid from a mixture of liquid one by one and collected fraction A, fraction B separately, and we can able to separate the pure fractions from a mixture of liquids. Hope you can able to understand fractional distillation technique. Thank you.
இந்த வீடியோ பிடிச்சிருந்தா லைக் பண்ணுங்க, ஷேர் பண்ணுங்க, கமெண்ட் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணுங்க. மறக்காம பக்கத்துல இருக்க பெல் ஐகானை கிளிக் பண்ணுங்க.